2,000 employees.
Probably more than that.
Maybe even
Yeah,
more than
over all
that.
the centers, yeah.
So we're definitely off the ground, and Laurie's here to tell us more about that. One or two more announcements. No, I think that's about it. Laurie is, and I asked her to give me her exact title because I couldn't remember it, lead for the research communication for NASA Human Research Program. So Laurie is here because she knows exactly what's going on.
Not all the time.
Thank you.
Can everyone hear me okay on the mic? That's okay? In the back? All right. Well, thank you, Walt and the Observatory, for having me here tonight. I was here a couple of years ago, and it's always a pleasure to come back and speak. And tonight I'm going to talk to you about how NASA is planning to send humans back to the moon and on to Mars. There we go. All right, so before NASA, I'll give a little bit about myself. I've been at NASA for 19 years, and it all started here. So this should look familiar to most of you. This is a picture of Jamestown from space, right here. You can see the ice on Lake Erie and Chautauqua Lake. And I wanted to be an astronaut since I was 7, but bad eyesight and poor hearing made me medically disqualified, so I went for the next best thing, which is aerospace engineers. And during my undergrad, I actually was hired by NASA, and I alternated one semester in Buffalo and one semester down in Houston. And I was offered a job to come work in Houston before I even graduated. So I packed up, moved down there. I was down there for 16 years. I met a born and bred Texan, and we got married, have 3 beautiful, wild daughters. And about 3 years ago, and he also worked for NASA, he got the opportunity to get a promotion up at Glenn Research Center in Cleveland. Now, since this is the closest NASA center to my family, we jumped on it. And my wonderful management in Houston is actually allowing me to do my same job, but just from an office in Cleveland. And before I go on, I just want to take an opportunity. I give a lot of presentations, but my family's not always in the crowd. This is a really unique night for me. So I wanted to thank my family, my mom and dad, Bob and Lynn Darling, and my brother Scott, my younger brother Kevin, who's just walking in right now. Thank you guys for helping to always make my dreams come true. Okay, so as Gary was saying, last Saturday was the 50th anniversary of Neil Armstrong and Buzz Aldrin landing on the moon. Really exciting time for NASA. So what have we been doing in the past 50 years? After we flew the Apollo missions, we did the Skylab missions, which was the first space station, American space station. Then we did Apollo Soyuz, where we were working with the Russians in a very cooperative way in space for the first time. We flew the space shuttle missions, and we have been flying the space station now for 20 years. Actually more than 20 years, but for 20 years we have had humans continuously on the space station. A lot of people don't realize that. Right now there's a crew of 6 up there, and it's always an international crew, and we'll be flying the space station for a few more years. And right now this rocket is being built. This is called the SLS. This is what's going to take humans to the moon and on to Mars. And when I say we've been a little busy, yes, this is quite a feat for 50 years. But what I want to talk to you about tonight is what we've been doing in the past few months. So at the President's direction, NASA has been charged to go back to the moon in 5 years. So by 2024, we're going to have a man and a woman on the lunar surface. Now we've been planning to go back to the moon and on to Mars. This is nothing new. We've actually been planning for a 2028 target. But the President has challenged us, and the NASA administrator has accepted to get there in 5 years. And NASA just released a really cool video on this, about 3 minutes long, so I'd like to show that. Hopefully it works.
"50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
This system is capable of being the catalyst for deep space missions
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable, that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice could be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
To prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
So, it's a pretty exciting time to be at NASA. Now, if I can only find my presentation, that'll be even more exciting. Let me go to the other one. There we go. Okay. And yes, that was William Shatner narrating that. So the plan, as they said in the video, 2024, we get boots on the ground in the moon. 2028, we have a sustained presence on and around the moon. And after that, on to Mars. And this lays it out in a little bit more detail. So Artemis is the name of the program. Artemis is actually the twin sister of Apollo in Greek mythology. So Artemis 1 is launching in about 1.5 years. It will not have humans on it. It's a test flight to test out the whole system. Artemis 2, about 1.5 years after that, it will have humans on it. So this capsule looks very similar to Apollo, but it's much bigger. And in between Artemis 2 and Artemis 3, we're going to be building the Gateway, which is the small space station that will orbit the moon. And then Artemis 3, by 2024, will take humans to the surface of the moon. So I get the question a lot. Why are we going to the moon? Why doesn't NASA just go to Mars? And it's a fair question. To get to the moon takes a few days. to get to Mars and back. It's a 3-year mission. And so I like to use the example of hiking. A few years ago, I was lucky enough to hike to the base camp of Mount Everest. Now I had to prepare and train for it, make sure I had the right equipment, make sure I was in the right shape and the right team support. Now, base camp at Everest sits at 19,000 feet, okay? The summit of Mount Everest sits at 29,000 feet, basically where airplanes fly. Now, it was a tough hike to get to base camp. It took a few days, almost a week. But to go from base camp to the summit takes weeks, if not months. And from that point, it's not hiking anymore, it's technical climbing. You need ice picks, you need crampons, it's all different equipment, you need oxygen to breathe. So if I decided to take up mountain climbing, would I go from base camp and decide to do Mount Everest next? No. I would do something closer to home. I would try some summits in the United States, make sure I knew what equipment to bring, how my body reacted. So it's the same thing. We're going to learn a lot going to the moon. We need to learn how to live on a different body in the solar system. And it's much smarter, much safer to do that as a stepping stone, a proving ground. So the moon is our proving ground to get to Mars. Now this is all great, but let's talk about the most complex and fragile part of the whole mission. And yes, astronauts are very cool in space. When they drink water, it's spheres of water. Their hair floats around, they get to eat space food. They even get to wear a really neat tether when they're exercising, just to hold them down on the equipment. But there's one problem. We were built for Earth. We were not designed and built to live in space. And so when astronauts travel to the moon and onto Mars, they're going to experience stressors like we've never experienced before. Now, next I'm going to talk about kind of the hazards, the problems, the scary parts about going to space. And you're going to think, why would any astronaut ever want to sign up? That's not for me. No, thank you. But the good news is that NASA's working on solving those problems, and our bodies are extremely adaptive. So if you guys attended my talk 2 years ago, this is going to sound a little familiar. Okay, we have 5 hazards of human spaceflight. And because NASA loves acronyms, it spells RIDGE: radiation, isolation and confinement, distance from Earth, gravity, or lack thereof, and environments that are hostile and close. You'll notice these are red and these are yellow. These are challenging, these are extremely challenging. Okay? And I love this picture because if you were standing on Mars, that would be Earth up there. Okay, so these 5 hazards, just like the human body, the systems don't operate independently. They all operate together, and when astronauts go into space, all 5 hazards affect the body and the mind. So, hazard number 1, space radiation. In space, a lot of people think it's empty. It's not. It has particles flying at basically the speed of light. And there are 2 main sources of space radiation: the sun and exploding stars. Now the sun, if you remember from school, your periodic table of elements, okay, 1 and 2, the light ones, hydrogen and helium, that is what's coming from the sun, in addition to protons. So think of it as like a light rain, a shower that's constant, it's always there. The other one, galactic cosmic rays from the exploding stars, back to your periodic table, you basically have protons all the way up through iron. Now, from the sun, we can shield against that a little better than the galactic cosmic rays. Galactic cosmic rays are basically a big, huge ball of hail. And it's almost impossible to shield against. And when they hit the human body, they basically go right through the body, rip through even your DNA, which can cause cancer. So on Earth, the good news is we are protected from space radiation by our magnetic field and our atmosphere. On the moon, there's very little to no atmosphere. There's really not a magnetic field. And so the astronauts are a little more exposed. But because they're on the surface of the moon blocks some of that. When we go to Mars, Mars has an atmosphere, so it blocks a little radiation, and the planet does too. Now, the space station, if you think of Earth as a peach, the space station is the buzz of the peach, okay? It's pretty close. It's 250 miles away, just basically from here to Utica. And so the space station still sits within the magnetic field of Earth. But astronauts on the space station get about 10 times higher radiation than we do on Earth. So astronauts on Mars, it's very similar radiation than on the space station. So this is one of our biggest challenges. The second biggest challenge, and I think is the most interesting, is isolation and confinement. I love these pictures because this one's my absolute favorite. Karen Nyberg, an astronaut who loves to sew, found random pieces of material and threading on the space station and sewed this in space for her son on Earth. So I don't think anyone's had a toy made in space before. But isolation and confinement, this is a big deal. You know, if you are in a spacecraft for 3 years, you don't see your family and friends, you get in an argument with one of your 5 crew members, you can't just walk outside, take a walk, cool down. And our cell phones are actually making this problem even worse because our phones allow us to connect to anyone, anywhere, anytime. And so when we go to Mars or even the moon, you're not going to have that. And astronauts on the space station right now, remember only here to Utica, when they call home, which they do on a daily basis to their family and friends in video chat, it's a few seconds delay. It's not that noticeable. When you're on the moon, it's a little bit longer. When you're on Mars, hey mom and dad, I made it here safely. 20 minutes later, they hear it. So glad you're there, sweetie. 20 minutes later, you hear it on Mars. So 40 minutes. The astronauts are going to be pretty isolated and confined. One of their favorite things to do on the space station is this right here. This is the cupola window. They love to go there. And this is Tim Peake. He's a British astronaut. That's their favorite place to go. They feel most connected to space. Up here, when the Apollo 11 astronauts came back, nobody was sure what germs or what they were carrying. So when President Nixon greeted them for landing, they weren't even allowed to interact. Okay, distance from Earth. So again, to get from here, launching to the space station, back down is a few hours. To get to the moon, it's a few days. To get to Mars, it's going to take you 6 to 9 months to get there. And then you have to wait there for about 1.5 years for the planets to realign, and then 6 to 9 months back. So pretty far. And this is, again, on the moon. That's what Earth looks like. And you saw the other picture on Mars, looking back at Earth. Now, when you're really far from home, you want to make sure that you've packed the right things. You're pretty familiar with what situations can arise, and you would know how to treat those situations. On the space station right now, the space station was designed to be operated by Mission Control in Houston. That means if a problem arises on the space station, the astronauts can take care of it, but really the work is passed to the control team on the ground, and it's a pretty large control team. When you're on the moon or you're on Mars, you kind of have to fend for yourself. The astronauts are going to be more autonomous on how if a problem arises where they have to fix something on the spacecraft, they're going to have to do it themselves. Or if they get a kidney stone, or if somebody gets sick, what do you do? So what we're doing is trying to figure out what types of medical situations are the most probable, and how do we have the astronauts diagnose them and treat them. And all of that fancy medical equipment at the doctor's office, too big, too heavy to fit in a spacecraft. So we have to shrink it. So you see here, the huge ultrasounds in a lot of doctor's office, it's the size of a laptop. It's a portable ultrasound unit, and they're learning how to self-diagnose. Another thing we're learning to do, you really don't want to eat freeze-dried food for 3 years. So learning how to grow plants and produce in space is really important, not just for nutrition, but for our mental health as well. Because remember, these astronauts are only going to see a handful of people for 3 years. Okay, gravity. Our bodies love gravity. Love it, love it, love it so much. And this picture looks like he's standing on the surface of the moon. He's actually a few feet off the ground. He's jumping up. This is my good friend and astronaut Mike Barrett. So this is what he looks like on Earth. And that's what he looks like in space. So why does he look different? When we're walking around on Earth, all of the fluid in our body naturally pools to our legs. And if you've ever taken a long car ride or a plane ride, and at the end of the day, you have sock lines on your ankles, that's all that fluid. Well, in space, something happens immediately. So without gravity pulling that fluid down, it goes up your upper body, kind of sits up here. So you get a puffy face look and a puffy face feel. Now the astronauts say that it's not only, uncomfortable, it actually changes certain things in their bodies. So if you've ever had a head cold, you can't really smell well, you can't really taste well. Same thing happens to the astronauts. Another thing, and this has become one of our biggest problems to solve, is that the fluid in their head pushes on the back of their eye and actually changes their eye structure, which changes their vision. And the severity of the vision change, it's quite a range. And some astronauts, when they come back to Earth, it goes back to normal, some it doesn't. So the vision issue in space, and I'll talk about that a little later, is one of our biggest problems. What else happens without gravity? So without gravity pulling you down, your bones and muscles start to weaken and deteriorate quicker. So how do we counteract for that? Because we don't want astronauts basically being mush when they get to Mars or the moon. So what we do is that astronauts on the space station, and this will be the same for all astronauts traveling, they are required to exercise every day for 2 hours just to maintain some bone and muscle health. So they have a treadmill in space, which you saw a picture of. They've got their harness to push them down, and they have a bike, and then they have a fancy resistive exercise device that uses vacuums. But that's on the space station, and the space station is really big, and we actually can't even use that same equipment in Gateway or the vehicle going to Mars. So we have to shrink that stuff down too. So gravity affects quite a bit of things, and it's pretty instantaneous. Oh, and one other thing about gravity. So we know on the space station, right, it's pretty much zero gravity, and on Earth it's 1 gravity, 1G. So space station astronauts are up there for about 6 months at a time. And we're pretty familiar with what happens to their bodies after 6 months. And it's going from 1G to 0G and back. Okay, when we go to the moon, it's going to go from 1G to 0G, about 1/6 G on the moon, and then back. Mars, it's going to be 1, 0, 3/8, and back, okay? And why I say this is because it's not just being in zero gravity that makes changes, it's actually that transition from one gravity field to another that causes problems. Because another thing that our bodies rely on for gravity is our sense of balance, our up and down. There's fluid in our ears and little hair follicles that help with our sense of touch and our vision to tell us what's up, what's down. Take that all the way in space. Okay, so when you launch into space, you kind of get that feeling. But the problem is coming back to Earth. Now, if anyone's ever watched a video of the astronauts when they land in Kazakhstan, which is near Russia, they don't climb out of the capsule themselves, and they don't walk afterwards. They are lifted out of the capsule, and they are put into chairs. There's a reason for that. They're not being lazy. They actually, even though they've maintained some bone and muscle health, they can't control them. And their sensory motor system, their sense of balance, is off. Now, that's okay when we land on Earth. But what happens when crews land on Mars? And some astronauts say they feel okay after being in space for 6 months. Some astronauts say they just want to curl up in a ball and vomit. So, again, we're all different. We all have different reactions to it. But one thing that the moon is going to help us do is learn about what happens when astronauts land on a different body where there is no big support team waiting for them up at the landing site on the ground. If there's an emergency and they have to get out of their spacecraft quickly, can they even walk around, or are they going to be so disoriented and nauseous and dizzy that they can't do it? So that's one area that the moon will really help us in getting to Mars. Okay, our last hazard is environments. Now this is Gene Cernan, who's looking a little dirty. He was one of the Apollo astronauts. And that's lunar dust. Now when we launched Apollo, and we knew the moon had some regolith, some dust to it, NASA wasn't really quite sure what it was going to be like. Some people thought the whole lander would sink into the ground like quicksand. Some people thought. Another thing is that Apollo, the lunar lander, did not have an airlock. An airlock is basically what separates the cabin from space. So what the Apollo astronauts do is they put on their spacesuits inside the cabin, they depressurize the cabin, and they walk down the ladder. That's okay going out, but when you're coming back in, guess what? You're bringing all that lunar dust with you, and it's not falling to the ground. It's floating around. And the Apollo astronauts said it had a very distinct gunpowder smell that they've never smelled anywhere on Earth. All the astronauts have said that. It has a really unique smell to it. And Buzz Aldrin and Neil Armstrong, it was so disruptive to have all this dust floating around that they actually slept in their spacesuits the night they spent on the moon to keep it off. And, you know, again, NASA tries to prepare as best we can. So before we went to the moon, we took the astronauts to deserts in the U.S. to practice collecting rocks. Now, no simulation is perfect, and the box they designed to collect the rocks works great on Earth, but in space it didn't seal properly, so a lot of that dust leaked out as well. So again, all good stuff. So this is the hostile part of environments. The closed part is, again, it's a closed spaceship. You can't open the window and let the breeze come in and kind of get your spring cleaning done. The space station and all spacecraft are a closed environment in that the microbes that we bring up and things that are on the equipment, it stays there. And its own unique, what we call microbiome. Okay, so astronauts are always this is Kate here, what she's doing, she's swabbing the surface. So they constantly swab surfaces, they swab, you know, their mouth, they take some other measurements, and they look at how their microbiome inside them has changed, and also what microbes are on the space station. One thing that's really neat about a closed environment, again, when you go to the moon or Mars, you better make sure you brought everything with you. And on the space station, 90% of the water they drink is recycled. Anyone guess what that is that they're recycling? Sweat and urine. And it tastes delicious, they say. It's actually, it's not as cleaner than what we drink on Earth. So no astronauts complain about the taste. But it's pretty neat. And so when we go to Mars and the moon, we're going to have to recycle or make all of the water that the astronauts need. Okay. So that's the really scary part. Now, how do we solve all these problems? Well, what my team is responsible for is solving them using astronauts in space and astronaut-like individuals on Earth. And so we utilize the International Space Station. The astronauts are up there for about 6 months at a time. And then we use a whole slew of really unique facilities all around the world. So on the space system, you know, those 5 hazards, some are greater than others, but when we go to the moon, some are going to be a little higher, and when we go to Mars, they're all going to be maxed. So what we're doing on the space station is really trying to understand what happens to the human body after 6 months in space. And then 6 months, 3 years. It's a big stepping stone, right? So what are we trying to do to kind of close that gap? Well, if some of you heard about, and I think he spoke at Chautauqua last week, Scott Kelly's year-long mission in his twin study, he was the first American to spend almost a year in space, 340 days in space. We learned a lot about what happened to his body after 1 year in space. But the problem is, it's his body. And if we all went into space, we would all react differently. So what NASA's planning is 10 more one-year missions. Because we really need to know, okay, we got 6 months now. What happens after a year in space? and then we'll be a little more comfortable with that 3 years to Mars. Now, how do we study people on Earth? These are all volunteers, they're test subjects, they have to meet similar qualifications as real astronauts, and they volunteer to go into some of these facilities for anywhere from 45 days to a year at a time. So, 5 hazards again. Radiation. Actually, out in Long Island at Brookhaven National Lab, there's a facility owned by the Department of Energy where we can simulate space radiation. Everything from protons to iron. Now, we don't put people in that, but we do put tissue samples in that, and we do put rodents in that, and then we try to figure out the rodent to human, the model translation. Isolation confinement. This is a great one that we can simulate on the ground. This facility here, it's a 2-story facility at NASA's Johnson Space Center in Houston. It's called HERA, Human Exploration Research Analog. So the crew is always 4 people. It's usually 2 males, 2 females, but not always. They go in that facility for 45 days at a time, and they simulate a mission to an asteroid. So what are we using this for? We are using this to study team dynamics, how do you even put a team together, a lot of the behavioral health, and they're coming up with really unique ways. If you are about to get in an argument with someone, right, certain things happen to your body. Temperature rises, blood pressure may rise. So one of the experiments we're doing is that they have wearable technologies, and the researchers on the ground can actually predict when 2 crew members are going to get into either an argument or a situation that's going to arise. So before that happens, they also have cool technology that's almost like a virtual therapist or counselor that tells the astronauts, you need to go sit down and do this self-assessment test and ways to cope with it. And it's a pretty important thing because you really don't want 2 crew members, 5 months into a 3-year mission, arguing when they can't go anywhere. Another thing they study in here is the food. One of the missions, they looked at meal replacement bars, as maybe an alternative. The crew really did not like that. Could probably, imagine it wasn't that tasty, even for 45 days. So they do a lot of isolation and confinement research here. This one up here, I wish it was bigger. So this facility is in Moscow, Russia. And the inside of this looks like a space station. Now, the Russians have used this for years. They have done a lot of isolation studies in here. NASA is partnering with them. We actually just finished the first mission. They're sending crews in there, and I believe it's 6-person crews, for 4 months, and then another crew for 8 months, and then another crew for 12 months. So what they do here is that 40-minute communication delay, they can impose communication delays on here. So they try to mimic a mission, whether it's a full 20 minutes or a mission to the moon or an asteroid. And the crew is pretty isolated and confined. Now they do, for all of these facilities, there is a support team on the ground if an emergency happens, yes. But it's a way to study what happens to people, especially the behavioral health, on Earth, which means it's cheaper, we can get a lot more data, and then we can try it in space. Down here, this is Antarctica. So we've got some research going on at a whole bunch of stations in Antarctica, and if you can't think of a more remote and isolated place in the world, I don't know what else it would be. So winter over in Antarctica is basically, the weather prevents anyone from coming and going. It's about 5 months during our summer. So what we do is that we study people in Antarctica to see how they do being isolated and confined from the rest of the world. Altered gravity, vomit comet. It's appropriately named. So it does parabolas, and when it noses over, you get a duration of seconds of microgravity or zero gravity. So it's a way for us to test some technologies. This facility down here, this is one of my favorites. That is in Germany, in Cologne, Germany. I can't believe you can move tower, but it's just an ugly white building from the outside. But inside it's really unique. So how could we test gravity in a building laid out? Okay, so the people in this study are actually put into bed rest for a few months at a time. And not just flat, we tilt their head 6 degrees down. So that fluid that shifts to your head does the same thing. Go hang upside down on the monkey bars or do a handstand and you'll feel that same thing. So we can study basically the fluid shifts to the upper body. Now, 2 other really neat things that this facility does. It's called NVHAB, Environment and Habitat. They can change the environment. They can pump up the level of carbon dioxide in the facility. Why would that be? On the space station, again, no air coming through, okay? We put oxygen in, we scrub the carbon dioxide out, but it is not as good as on Earth, and so you have higher levels of carbon dioxide on the space station. Also, with no air naturally flowing, we have fans to move the air artificially, but you do get pockets of carbon dioxide. So the astronauts say that the higher carbon dioxide gives them a little bit of fuzzy head, they can't think clearly, so we can test that in here as well. And one other neat thing that this facility does is it has a huge centrifuge in it. So if you swing your hand around, you feel the blood kind of going to your fingertips. Okay, you gotta spin a lot. And what they do is that in their 6-degree head down tilt, which by the way, they have to go to the bathroom, head down, shower, eat, even exercise. They have a cool vertical treadmill that they use with a harness. They do everything in that 6-degree head down tilt. So they have this big centrifuge, and so the test subjects are rolled onto there on their bed, okay, with their feet pointing out, and it spins them for 30 minutes a day. And now, sounds awful, but if you have had your head tilted down, that's actually a relief, because where does the fluid go? Back to your legs. So, we are trying to see if artificial gravity, basically a centrifuge that spins, how that counteracts fluid shifts. So when we design that vehicle to go to Mars, is it worth it to try to put a centrifuge inside that vehicle? And soon we will be going to the moon. So again, the timeline is the next 5 years, we'll be sending humans to the moon. By 2028, we'll have a sustained presence there, and we're going to use that as a proving ground to get to Mars. And just like that Everest analog, or example, the moon's going to be great to show us how to transition from one gravity environment to another without a ground support team there. How does, the radiation, once you get outside, the magnetic field affect the astronauts, the team performance being so far away from Earth. So we're going to be able to basically try it on the moon and then on to Mars. I get the question a lot of, why are we spending money on NASA? Why would I give my taxpayer money to a space agency when there are potholes in Jamestown, the infrastructure in the U.S. is crumbling, the medical system is not where it needs to be, thousands of kids are without access to fresh food? Get it. So what I try to do is explain what we do with your taxpayer money. So if I had $1 of your taxpayer money, take 1 penny of that. Not the whole thing, NASA gets a portion of that. So with that portion of a penny, I could tell you that NASA inspires the next generation of explorers unlike any other. And if there's a kid here tonight that was as ambitious about space as I was, you guys are going to be the ones going to Mars. Okay? It's not going to be us. It's going to be you guys. I can tell you that for every $1 you spend for NASA, you get about $8 back in your pocket through the technology advances that you use every day that you're not even aware was brought to you by NASA. I can tell you that the partnerships we have with the internationals, with the commercial companies, that it's great for the economy. And I could tell you that exploring is in our DNA. Civilizations that have stopped exploring could actually cease to exist. But my favorite answer, and I'm I'm not taking credit for this because this was from Bill Nye, the Science Guy. He said, think of what happened when we went to the moon 50 years ago. Think of what it did for the United States, and think of what it did for humanity. It literally changed the world. I believe that when we go back to the moon and onto Mars, that's what we're going to do. We're going to change the world. Thank you.
Thank you very much, Laurie. What we would like to do is take about a couple of minutes break in case somebody would like to get a soft drink or visit the restroom, and then Q&A, question and answer. I think Laurie has some even better answers than she said so far.
I don't have all the answers for everything.
So we would love to invite you to take part in that. Give you about 5 minutes and we'll reconvene right here. Take a look at what's really out there. The universe only has two parts, planet Earth and everything else. So here's your chance to see everything else. You may have seen all sorts of movies and so forth about space. I grew up with Captain Kirk. But when you see through the telescope, it's almost like being there the whole experience. So, Laurie, take it from here. If you have any questions, please raise your hand. And by about quarter of or so, we'll see if the sky will be open.
All right, thank you. Now, again, I can't promise I know the answers, so I will try my best.
On this International Space Station, do they have some way of filtering, like you were talking about the dust that was in one of the things? Do they have some type of filtration to take dust and stuff out of the air?
Yes, they do. They do have filters, and they have to clean them on a regular basis. And they always say it's always interesting what you find in the filters. A little different than cleaning your filters at home, but yes, they do. They scrub the air. Yeah.
Have the astronauts already been chosen for the next moon mission?
They have not chosen the astronauts for those missions. They recently chose a few months ago. So right now, the only way to get humans into space is through the Russians. We use the Russian Soyuz, so it launches from Kazakhstan. But NASA's been partnering with U.S. commercial companies, and they did pick, and those commercial companies will launch from U.S. soil and launch astronauts to the space station. They just picked those crews that will probably be flying later this year, but not yet. It'll be exciting when they announce that.
When 24, when you actually go to the moon, and then 728, when you go to Mars, how long will people be staying on the moon, and what kind of, somewhat?
That's a great question, and I should have mentioned that at first. The duration of mission. So again, space station mission is about 6 months long. To the moon, what they're proposing right now is that the astronauts would be on the gateway orbiting the moon for 1 to 3 months at a time, and they would go down to the surface for a week at a time, and then back up to the space station. Now, as we have a more sustained presence there, they might expand that time, but that's what they're building the vehicles now, to hold up to about a 3-month mission around the moon, and about a week at a time on the surface.
Are they going to be building anything on the moon?
Yes, so they're looking at building different habitats on the moon. And those plans, because I believe in April or May is when we got the direction for the 2024. A lot of that now is replanning, and it's all kind of vague, and the dust is finally settling on that, no pun intended, to figure out, what are we actually going to have on the surface, because we had a plan to get us there in 2028, and now we're saying, how can we scale that back to get there by 2024, and then slowly build up back to that 2028 plan.
So, to be clear, you always were going to go to the moon first before you went to Mars? You just wanted to
Yes. However, NASA is under the executive branch. So whatever the president decides for NASA is our goal. And so under Bush, we had Constellation, which was going to go to moon and onto Mars. Under Obama, they took the moon out, and we were going to go to an asteroid and then Mars. Under Trump, we're going to the moon and Mars. So that's kind of, Mars has always been the goal, but where we go before then can change with a new president.
Maybe the moon don't like illegal aliens.
Oh, boy. Next question.
Micrometeorites. How big a danger and what can you do?
Well, so for the space station, I mean when we go to the moon or Mars. For the space station, because there's quite a bit of space junk orbiting Earth, and if you see a visual of it, it's astounding how much space junk is there. And when I say space junk, it's either satellites that have been decommissioned, they run out of prop, or they have a failure, or they've collided. And that's the worst, because when they collide, then you have pieces going everywhere. So we work with the DoD to track a lot of that debris, the space debris, but we can't track every little piece, but we can track the bigger pieces. And for the space station, when we know that one is coming, we can reboost the space station. We can change the orbit to get it out of the path. So that's what we do right now with the space station. And you do find that astronauts will say when they do spacewalks, they'll see holes through different parts, which are tiny micrometeorite debris, holes through it. Again, these are ones we can't track. They're so small. When we go to the moon and onto Mars, again, we're going to rely on tracking capabilities. And a lot of people say they believe in the big space theory, that space is so big that the probability of that happening is small. I mean, spacecrafts are typically made out of aluminum. It's lightweight. It actually does protect against some types of radiation, but it can puncture easily. So, yeah, it is a risk. I didn't put it up here because what we track is risk to the body, and that's actually more risk to the spacecraft. It's going to damage the spacecraft first. Then the body. Yeah.
There's one there.
Oh.
Me?
Yes.
All right. Scott Kelly's DNA changed by about 7% just from a year on the space station. Do you believe that could be a danger going forward?
Yes, I'm so glad you brought that up, because this is actually a misconception. His DNA did not change. If it changed by 7%, he would be a banana. His DNA did not change. His gene expression changed. So your gene expression changes when you go through a stressful event. Okay, that changed by 7%. And it kind of got a bad rap. Actually, they wrote a whole story on how it spun out, the media spun this out of control, that he was no longer a twin. But what we did find from Scott Kelly's mission, two very unique things. One, his body adapted extremely well to space, and then adapted when he came home. The other thing is telomeres. So telomeres are little end caps on your chromosomes, and as we age, they shorten. Okay, so what we expected is that when Scott Kelly went into space, his telomeres would shorten quicker than they do on Earth, but they actually lengthened. And then, when he landed back on Earth, within hours, they shortened back to where they were before he launched. This was completely unexpected. Those one-year missions we're doing, we're going to be doing the telomere study on that too. So, great question. Kudos on knowing the twin study. But we did, that was the first time, not only did we have someone in space for that long, but he just happened to have an identical twin. And it was his idea. Scott Kelly said one day, hey, would it be beneficial to bring my twin brother into this? Now, Mark Kelly was an astronaut as well. He's long, retired from NASA. But it was a great study in nature versus nurture. Scott Kelly was in space, and Mark Kelly was on the ground. And identical twins have nearly identical DNA and genetics. And so we thought whatever changes that we saw from Scott would be caused by spaceflight. Great question.
Thank you.
Yes.
I know something about space.
You do what you know.
I know that there's barely oxygen and it's so cold.
Yes. Do you also know that it can be super hot? So astronauts, when they go on a spacewalk, they have a really thick spacesuit that's 13 layers deep. And there's a reason for that. When the sun comes up in space, it's so hot. But when the sun's on the other side of Earth, it's so cold. And did you know that astronauts in space see 16 sunrises and sunsets a day? It goes around the Earth every hour and a half. Can you imagine that? It's time to get up, time to go to bed. Actually, they have really neat lighting that now you can get on your smartphone that takes the blue light out. Blue light is what keeps you awake. So they have really cool lighting on the space station that changes as the signals are taking rhythm. So you can get that on your phone. So for all of you that look at your phone at night and you wonder why you can't get to sleep, don't look at your phone or download the app. It's not a NASA app, but it was, partly developed. Yes?
Based on your own take, your own experience, of the 5 or 6 danger areas that you listed and how they're going to be attacked, what do you think is the most difficult?
I think it's the isolation and confinement. Yeah. I think humans, we're very social animals. We're used to being connected. We're used to seeing family and friends. And that's kind of where space radiation has always been one of the biggest challenges. But the isolation and confinement, I think, is going to be just as big of a challenge. And one thing they're doing, when it's your birthday in space, going to Mars, they're looking into having pre-recorded virtual reality of your family singing you happy birthday. So little things like that, could make a big difference. So I think it's the isolation confinement.
How long will be a tour of duty for any astronauts?
Great question. They are limited, astronauts are limited by a few things. One of the big things is radiation. So astronauts are considered radiation workers. And once they've hit their limit, they can't fly anymore. Some of them also, maybe certain health aspects will make them not suitable for flight, but a lot of times what we say is they have permissible exposure limits for radiation and for other items. So a lot of times it's the radiation
But
limit.
if they reach that limit on the moon, how will they get back?
We won't let them. We won't launch them before they reach that limit.
So you know the
So-
limit before.
Yes, yeah, we know what everyone's limit is. Now, what NASA does, how we say what is the limit, and why would you just, another thing that's hard to work in the human research area, is that some people say just send the humans, take the risks, what does it matter? Well, for radiation and cancer specifically, because that's the big one, we can't have astronauts have more than a 3% increase of getting cancer from these missions. Now, you have more of a chance of getting cancer if you smoke, if you don't exercise. So there's certain lifestyle changes or certain lifestyle habits that will get you, that are larger than that 3%. So, but 3% is what we basically.
Well, that's not quite what I was looking for. Once the astronauts are sent to the moon, they do the work up there, how do they get back?
How do they get back to Earth? So they would launch from the lunar surface back up to the gateway, and then from the gateway they would take the Orion vehicle. So the Orion vehicle is the one that looks like the Apollo capsule. So that's what's going to launch them. Basically, that will sit on top of a rocket and get them to the gateway, and then they'll take a lander down to the lunar surface, and then from there they'll take another ascent vehicle up to the gateway, and then they'll take Orion back home.
I think he meant, what if there was a spike in radiation or something, and then the astronaut all of a sudden has this health risk that is unforeseen and has to be removed from the program? Would it be something that is intense right away, or would they have to finish the mission and then take that as a risk to themselves?
Okay. The space radiation field is pretty well characterized. We know what the astronauts are going to get hit with. Now, the one thing that can change is a solar storm. So if there's a solar storm, most of the time we can predict it in time to warn the astronauts to take shelter. And so what they would do, like in the Orion spacecraft, their shelter is going to be under a whole bunch of cargo and bags to put some material between them and the radiation pit. They're also looking into wearables, like a vest that could prevent or lessen the radiation that hits them. Water is also a great way to shield. So habitats maybe on the moon or Mars could actually use water as shielding.
That was another, I had raised my hand. In the video, they had brought up the water molecules and everything, and I was wondering if that would be a resource for the mission to Mars. Is that something that they're looking into, is using the moon itself?
Yes, they're looking, from Mars they're looking at launching from Gateway, getting to Gateway, launching from Gateway and going to Mars.
Okay.
Yeah.
In old science fiction movies, maybe most famous one in 2001, Stanley Kubrick's, the space station was a wheel that spun and created artificial gravity. Is there any thought of that type of a space station or vehicle?
Yes. I mean, they're looking at artificial gravity, a centrifuge. Now the question is, to get any type of rotation in space, it has to be massive. And so they're looking at the trade-off of, are there any other technologies, that you don't have this massive wheel basically on the spacecraft. But yes, they are looking into artificial gravity.
You mentioned the radiation that particles go through, and also there's different kinds of radiation. Persons shielded by the cargo, etc., from the radiation. What about the radiation that builds up in that cargo?
Yeah.
Within this thing, and as they come out, by touching it and stuff like that. I mean, with our nuclear power plants, we have issues.
Yes and no. So space radiation is traveling so fast, has so much energy that it's transient.
Okay. Right.
However, when, say, a galactic cosmic ray, one of the exploding stars, one of the heavy ions, comes through and hits the side of an aluminum spacecraft, it actually makes it worse. It fragments like a shotgun. So now you have what they call secondaries. And so it's not just one straight shot, it's now you now have these multiple heavy ions.
Do the micro hits get worked out by the astronauts in order to eliminate them at all? Is there any way they can do that?
For the radiation?
Yeah.
They're actually looking into pharmaceuticals, like taking a Tylenol a day, and how that actually helps repair their DNA and minimize that.
I was just talking, that's good. That's a good answer, but I was thinking about the spacecraft itself. I mean, I'm picturing this, a lot of holes, little tiny holes, but is there any way that they, and after a while, those little tiny holes will get too big, I would think. But is there any way that they try to do any repair?
So the radiation won't physically cause holes, but the micrometeorite debris will cause holes. But it would probably be so few holes that it wouldn't make the structure unsafe. Yeah, but they do, like even on space station, they will repair. The spacewalks, half of them are to repair broken items.
What's the latest on the projected Department of Space? I heard that the president was suggesting that we take NASA away from the Air Force and create this new co-equal branch of the military.
Space Force, yes. So that has kind of, as I understand it, I don't know a whole bunch about it. As I understand it, NASA would stay separate. That would fall under the DOD. And NASA is still outside of the military. So I don't know a whole bunch on the Space Force.
So NASA doesn't fall under any branch of the military now?
No.
Oh.
NASA falls just under the executive branch.
Thank you.
Yeah.
Thank you, everybody. I don't know if you want to take a couple more.
Yeah, I can take a couple more.
Okay.
I got a couple questions for you. once they do make it to Mars, are they going to colonize it, or is there going to be some way to get back?
So
back to Earth.
they'll always have them have a way to get back. Now, I heard Buzz Aldrin speak one time, and his thought is that it should be a one-way trip. Everyone's entitled to their opinion, but NASA is safety first, so we will always have a way to have them come back. Now, years in the future, colonization is definitely an option.
That and have you heard anything about the James Webb Space Telescope? Are they close to launching that?
I don't know the latest schedule. I know they have been behind schedule a bit, and I'm not sure of the latest launch date. I don't know if anyone here knows the latest.
October, John Mangus, the chief optical scientist in building the Webb Space Telescope, will be our speaker.
Is NASA worried about any possible adverse effects on the moon itself from landing and launching and colonizing or harvesting ice for water?
Yes, and they actually hired a planetary protection agent for that. A lot of people joked about that, but yes.
There is one? There's an agency?
There's not an agency, there's a position within NASA.
Oh,
Planetary protection position. Yeah, we want to make sure we don't, cause any negative effects. Yes.
This program for landing on the moon must require quite a few resupply missions. And that seems like it would become quite expensive. Are they planning on using any recoverable components to the spacecraft?
Yes.
Like SpaceX?
They are planning on, the plan is still formulating, but a reusable lander. We're partnering with the commercial industry to build a lot of those. And your point about resupply, what's interesting with that is that, yes, they'll send the supplies there before we send the people. And it's the same with Mars. And one of the challenges, this brings up something I wanted to mention, with a Mars mission, you want to know your supplies got there, that your food is there waiting for you before you get there, and, nothing to eat. But the problem with that is that you want to know it got there, and then you would launch the crew. So we have to have food and medicine that is not just safe, nutritious, and effective. Make sure it's not unsafe for at least 5 years, 5-year shelf life. So that's one of the things they're studying now. It's basically long shelf life of pharmaceuticals and food. Okay, how about one more question?
You keep, every time you say something, you add more on.
I'm starting to talk all night.
I mean, as far as personnel. Do you have any idea how many personnel are working full-time on this mission?
On Artemis? Well, I know at NASA, so there's 10 NASA centers around the country. And right now, NASA's budget, we got an increase. They called it a down payment on the Artemis program. And so they're sorting out which centers. Like Johnson Space Center is the center of human spaceflight. Glenn Research Center does a lot of propulsion and power. A lot of the research centers have specialties. So they're trying to sort out how many people basically get assigned to each of the centers. So I don't know that yet. That's in the works right now.
All right, thank you very much.
I brought goodies for everyone, so you can get an Apollo sticker and a very unique Apollo footprint pin.